So down here at number 1, I wrote this A matrix, which we were trying to find using these values. Here's our eigenvalue, here's our eigenvector is equal to this. And this is because I have it written somewhere. That up there, my matrix A times my eigenvector is equal to my eigenvalue here times my eigenvector. And then doing this, I used it to create these equations down here, which I was able to figure out that. And then I wrote my other one, and I was able to figure out a little bit more. And then I plugged in my values from my other sides, and I ended up getting A's 1, C's 4, B's negative 8, and then D's 5. I then plugged all of those numbers from all that into here, and then I got my matrix A. I then took my new vector that I wanted, which is from up here, and then transformed it by this A, and I got that there, the negative 15, 6. And then for part 2, well, part 2 of the question, we were supposed to rewrite this vector into the eigenvectors. So I took that one plus that one, and then I solved for A and B. A is 1, B is 1, and then that checks out. Then over here I wrote fancier notation, I guess, but this new vector is equal to the 1 v1 vector, eigenvector, plus the 1 v2 eigenvector. And then I was just like, okay, this is what that means. And that means this. And then I can put my eigenvalues in front of my eigenvectors and add them because of that. Eigenvalue 1, eigenvalue 2, and then get this. Then part 3 of it is looking at it from like a sketch. So here I have my vector 1, 2 here. And first I showed how this here is a combination of these two. So I drew this one once, and then I drew this one originally over here, but I ended up sliding it over here so that way I could create the point here. And then not using this, but like understanding this is really important for this part. So for this here, because I could have had this here go here and then add that one, but I did it that way, the same as the other. So what I did here is I took my original eigenvector, and then I said, okay, I'm gonna times it by negative 3, and then create this point here geometrically. And then from this point, I'm gonna add on this here, which is this blue vector times the 9. This is at a different scale, which is kind of important to understand when looking at this geometrically, because I didn't have room to keep them on the same scale, so I changed it a little bit. For this last part, this is part 4, understanding basically that these are the same. So my p-value is equal to the two eigenvectors. So eigenvector 1, eigenvector 2 is equal to p, but like together. And then my d value is the eigenvalues. So one up there, because this one here corresponds with that. So when I multiply p and d, this is going to correspond with the one vector, and this here is going to correspond with the other vector. My a value comes from here, and then I did this handy dandy little formula figuring out the determinant of p, and then it's just a formula to get the inverse of p. Then I did all of this handy dandy multiplication stuff. I times this vector by that first to get this, then I took this and times it by that to get this, and then all that times that p to get that, which is the same answer we got here, which basically shows that this is the same operation, but this is more parts. So is equal to that, and we're just verifying that.